Alright, today we're going to be talking about the really special parallelograms. One is a rhombus, one is a rectangle, and then you have the mother of all quadrilaterals, which is the square. It means it's going to have all properties that the rectangle and the rhombus have. Okay, so if you take a look at the core concept, a rhombus is a parallelogram with four congruent sides. So you can see that the consecutive sides, meaning the ones right next to each other, are indeed the same length. A rectangle is a parallelogram with four right angles. You can see here that we have four right angles. And then a square, all the sides are congruent, and it also has four right angles as well. And I saw this chart and I thought it was great. It had it all just laid out for you. So when you have a four-sided figure, it starts off as a quadrilateral, and as you come across different characteristics, it falls underneath all these different categories. Well, if you have two pairs of parallel sides, you have a parallelogram, and then if it has four right angles, then it goes underneath the rectangle, and say it has all your sides congruent, it ends up being a square as well. So this would be something that's good to write down. And we'll talk about it more in a little bit. Okay, so this brings us to our corollaries. A quadrilateral is a rhombus if and only if it has four congruent sides. Now, in order for a rhombus or a quadrilateral to be considered a rhombus, it must be a parallelogram first. Okay, so in order for any of these to be true, you have to have a parallelogram first. Okay, so a rhombus is going to have the same characteristics as a parallelogram, plus on top of it, you're going to have all four sides are congruent. You have the rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. It still has to be a parallelogram first. Okay? And for a square, a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay? So it has to be both of these shapes in order for it to be a square. Here's something else that I saw that was pretty cool. It's a Venn diagram. We have our parallelograms. They have a few characteristics. Then we have rhombuses that have four congruent sides. We have rectangles that have four right angles. And when these two things overlap, you end up getting what's called a square. And that's why I call it the mother of all quadrilaterals. Okay, and that brings us to our first example. It says, for any rhombus QRST, decide whether the statement is always or sometimes true, and then draw a diagram to explain your reasoning. Okay, so I'm just going to draw a parallelogram, and since it's a rhombus, that means all my sides are congruent. That's QRST. And one thing that you need to remember is when you're naming something, if you start at one corner, you have to go around. You can't just jump around and say this is Q and that's R. It doesn't work that way. Okay? So make sure you're labeling around your shape. Okay. So QRST. And we want to see if angle Q and angle S is always or sometimes true. Well, this is going to be always, and because it's a rhombus, it means it's also a parallelogram. And we know that in parallelograms, opposite angles are congruent. Okay, so that's always going to happen. The opposite angles are going to be congruent. And if we look at B, and we draw our picture, QRST, and it's saying that Q is going to be congruent to r. Well, the only time that's ever going to happen is if it's straight up and down and they're both 90 degrees, because the two consecutive angles right next to each other add up to equal 180. And if you have this being x and that being x, you have x plus x equals 180, 2x equals 180, so that way x would have to be 90. And the only time that's going to happen is when they're 90 degree angles. Well, that's not always, that's just sometimes. Alright, so this brings us to our characteristics of our rhombus. Okay, so the rhombus diagonals theorem. If a parallelogram is a rhombus, if and only if their diagonals are perpendicular. So that's something that's new. Not only are the diagonals bisected, because we know that being a parallelogram, we also know that a rhombus has to have a right angle for its diagonals. Also, the rhombus opposite angles theorem. If a parallelogram is a rhombus, if and only if each diagonal bisects a pair of opposite angles. So, if you take a look at this picture, okay, A is split up into two congruent angles, okay, and C is also split up into two congruent angles. So we see here that we have 4 total congruent angles. And if we look at D, we have 2 congruent, B is 2 congruent, and now you can see that we actually have 4 congruent angles right here. Okay, so just know that a rhombus bisects its opposite angles. Okay, so this brings us to our next example. It says, find the measures of the number of angles in the rhombus A, B, C, and D. Well, since we know that it's a rhombus, okay, we know that the diagonals form a 90-degree angle. So angle 1 is 90 degrees. And I also know that the diagonals bisect a pair of opposite angles. Well, here I know that half my angle is 61, so I know that the other half has to be 61 as well. Same for angle 2 and angle 3. They also need to be 61 degrees. Okay, so that just leaves angle 4. Well, you can see, if I redraw this, if this is 90, this is 61, I should be able to figure out what my third angle is, because I know all the angles in a triangle add up to 180. Okay, so 90 plus 61 is 151, so 180 minus 151 should give me 29 degrees. Okay, so angle 1 is 90, angle 2 is 61 degrees, angle 3 is 61 degrees, and angle 4 is 29 degrees. Now that we've done some examples with rhombuses, let's go ahead and move on to rectangles. Alright, so the rectangle diagonals theorem says a parallelogram is a rectangle if and only if its diagonals are congruent. So, here we have 4 right angles, and we have that each piece of our diagonals are congruent. Okay, so let's try an example. So, example 5, it says, in rectangle QRST, QS is 5x minus 31, and RT is 2x plus 11. So find the lengths of the diagonals of QRST. Okay. Well, first thing I'm going to do is, since I have a picture, I'm going to label what I know. So QS is 5x minus 31, and I know that RT is 2x plus 11. And since it's a rectangle, I know that these two diagonals are going to be equal to one another, so I'm going to set them equal. 2x plus 11 equals 5x minus 31. Okay, I'm going to get x's on one side and numbers on the other. So I'm going to subtract 2x from both sides. And I get 11 is equal to 3x minus 31. I'm going to add 31 to both sides, and I get 42 is equal to 3x. Divide by 3 on both sides, and I get x equals 14. Okay. But I need to go back and look at my example, and or my question. It says find the lengths of the diagonals. I found x, but I didn't actually finish my problem yet. So I need to take that and plug back in for x. It doesn't matter which one I plug it in for, because I know that those two are congruent. So if I take 5 times 14 minus 31, I get 39. And that's my answer. Alright, the last example we're going to do is identify a parallelogram in the coordinate plane. And we're going to decide whether A, B, C, D with vertices A at -2, 6, B is at 6, 8, C is at 4, 0, and D is at -4, -2 is a rectangle, rhombus, or square. Okay, and we're going to give all the names that apply. Well, on a rectangle, we know that the diagonals are congruent. Okay, so we can actually find the lengths of the diagonals and compare them. Or we know that rectangles have a right angle. So what we can actually do is take the slope of two consecutive sides and see if they're opposite reciprocals of each other. And I think that would be the easiest way to do it. Okay, so slope of AB. And we know that slope is rise over run, so we're going to rise 2 over, let's see, 2, 4, 6, 8. And for those of y'all watching, your grid is going by 2's, so you have to be very careful. So 2 over 8 reduces to 1/4. Okay, so now I'm going to do the slope of AD. Okay. So my rise, 2, 4, 6, 8 over 2, which reduces to 4. Now, in order for it to be a perpendicular slope, it has to be the opposite reciprocal. Okay. In these cases, they are reciprocals, however, one of them is not negative. Okay. So in order for this to work, this should have been a negative. So it's not a rectangle. Okay. And we know since it's not a rectangle, it cannot be a square. But we can check to see if it's a rhombus. Now, a rhombus, we can either see if the diagonals are perpendicular by checking the slopes, or we can check a pair of consecutive sides to see if their lengths are the same. Okay? Since we did slope on the first one, let's go ahead and do the distance formula on the second one so you can have a refresher. And if you recall, the distance formula is the distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. So if we're going to take the distance of AB, and we're going to take the distance of BC, because those are the two lines that are right next to each other. So AB will make blue, and we'll make BC green, and we can see if they are the same length. So if I plug in the numbers, okay, I'm going to let -2 be x1, 6 is y1, B6 is x2, and 8 is y2. And we end up getting 6 minus -2, that's a parenthesis, squared plus 8 minus 6 squared. So if we actually put that in our calculators or we reduce it, we end up getting the square root of 68. Okay. So let's see if BC ends up being the exact same. Okay. You want to make sure you actually label, so I'm just going to keep B as x2, y2, and I'm just going to make C x1, y1. And when we plug them in, we get 6 minus 4 squared plus 8 minus 0 squared, and if you plug that into your calculator, you should get the square root of 68 as well. Okay, so those end up being the same, so this is actually a rhombus and parallelogram. Okay. Of course, we're going to be doing more examples in class, and make sure you're asking your teacher questions so that way you don't get behind.